Hello everyone. In today's session, we'll have a look at properties of multiplication of integers. Let's look at the first property, closure. In multiplication of integers, we have three situations. One, where both the numbers are positive. Second, where one of the numbers is negative and the other is positive. And the third is both the numbers are negative. Now, the situation one, which is both numbers are positive, is as good as situation for the whole numbers. And we know that whole numbers are closed under multiplication. So we will not look at situation one. So now let's look at the remaining two situations. Let's take one positive and one negative number, plus 5 and minus 3. So when we multiply plus 5 by minus 3, in the answer, first we multiply the weights. So 5 and 3, 15 is the multiplication of the weights. And for the sign, we look at how many negative numbers are there as multipliers. We have only one negative multiplier. One is odd, and odd always results into negative sign. So the answer is minus 15. Now here we can see that plus 5, minus 3, and minus 15. All the three numbers are integers. And hence we can say that in this case, integers are closed under multiplication. Now let's take this third situation which we wanted, that is both the numbers are negative numbers. So let's take minus 5 and minus 3. Now multiplying minus 5 by minus 3, we multiply the weight. So 5 into 3 is 15. And for the sign, we look at how many negative numbers are there in the multiplication. There are two negative numbers. 2 is even, and even results in positive sign. So now here the answer is plus 15. So the answer and the multiplier, which is minus 5, minus 3, and plus 15, all these three are integers, and hence we can confidently say that integers are closed under multiplication. Let's talk about commutative property. We know to check whether the integers are commutative under multiplication, what we need to do is to interchange the positions of the multipliers and see if the results remain same. Again, we are not going to check this situation where we have two positive integers, because that situation is already covered under whole numbers, and we know that in that situations multiplication is commutative. So let's take a situation where we have one positive number and one negative number. So let's multiply plus 5 with minus 3. What we get is 5 into 3 is 15. The multiplication of weights plus minus one negative sign gives result minus sign. Let's now interchange these positions and let's do minus 3 multiplied by plus 5. So that is equal to, again we have to first multiply the weights. So multiplication of weights gives 3 into 5, 15. Again, only one minus sign in the multipliers. That means the final sign is minus. So now we see here that even if we change the position of the integer, the result remains same. Let's see the third situation. Let's take two negative integers, minus 5, minus 3. First, let's multiply minus 5 by minus 3. Multiplication, we need to multiply the weights. 5 into 3, 15. Two minus signs, even number of minus signs means the result is plus 15. Now we change the position, we do minus 3 multiplied by minus 5. That gives again multiplication of weights. 3 5s are 15. Two negative numbers, even number of negative numbers means the result is positive. And now in this case also we see that both the results are same even after changing the position of the integers. And hence now we can say that multiplication is commutative in integers. Now let's talk about the associative property. In associative property, we see whether the change of order of operation results into same result. If it happens, then we say that that operation is associative. So let's take three integers, -5, +3, and -4. Now first let's do -5 into +3. So first let's do this and then multiply it with -4. And in the second case, what we will do is we'll do -5 into +3 multiplied by -4. We will do this first. So first we are going to multiply -5 and +3, and in the second situation we are going to multiply +3 and -4 first. Let's do this side. So 5 and 3 weights, multiplication of weights gives us 15. Only one negative integer, which means it's an odd number of integer, or odd number of negative integers gives us negative sign, multiplied by -4. So now again multiply the weights. 15 fours are 60. Two negative integers will result into a positive sign because they are even number of negative integers. Now let's do on this side. First, let's keep -5 as it is, and let's do the calculation here first. 3 into 4 weights, 3 into 4 12. Sign only one negative number, odd number of negative numbers gives minus sign. Now in this case, -5 -12, let's multiply the weights. 12 5s are 60. Now here two negative integers, which is even number of negative integers, gives sign +60. And now we can see here clearly that both sides the result is same. It does not change. And hence we can say that multiplication is associative in integers. In multiplicative identity, we want to know a number which when multiplied does not change the original number. For example, if I have -5, which number I should multiply so that I get the answer also as -5. Now we know in integers the answer is same as multiplication of weights of the multipliers. So now the answer is 5 and one of the multipliers is 5, so which means the second multiplier has to be 1. Then only the multiplication of the weights will remain 5. Now let's look at the sign. The answer sign is minus, which means that on the multiplier side we need to have odd number of negative integers, and we already have 1 -5, so the second integer will not have the negative sign, so it has to be plus sign, so it is +1. Let's take another example. We have 13 multiplied by something should be equal to 13. Now what happens here? The multiplication of the weights of the multiplier should equal to the result. So 13 multiplied by something should be equal to 13, and so 13 multiplied by 1 is 13. Now regarding the sign of the result is plus, because there is no sign which it is a positive sign. So if it is a positive number, we need to have even number of negative numbers or no negative numbers. Now 13 is positive, so we cannot have 1 as negative. 1 also has to be positive, and hence what we can say is 1 is our multiplicative identity. Let's now see what happens if we multiply by 0. So we want to see What is the result if we multiply any integer by 0? Let's take example. 3 multiplied by 5 is equal to 15. 2 multiplied by 5 is equal to 10. 1 multiplied by 5 is equal to 5. So here we see that we are changing the multiplier, or we are reducing the multiplier by 1. So we are doing -1 every time. And we see here that the answer changes by -5. Now, what will happen when we change from 1 to 0? The answer has to change from 5 minus 5. 5 minus 5 is 0. So if we see here, the answer also changes by -5 as we change the multiplier by -1. So 0 multiplied by 5 will give 0. That's true for the positive integer. Let's look at the situation for the negative integer. Let's take negative integer. So 3 multiplied by -5 is equal to -15. 2 multiplied by -5 is equal to -10. 1 multiplied by -5 is equal to -5. So what is happening here is I am reducing the multiplier by 1. I am reducing it by 1, and here for the answer what is happening is the answer is increasing by 5. So it is becoming +5. So what would happen if I reduce the multiplier further by 1? The answer has to be increasing by further by 5, correct? So let's see what happens. So from 1 minus 1 is 0. So 0 into -5 is equal to -5 plus 5. -5 plus 5 is 0. So whenever we multiply any integer, now in this case +5 we multiply by 0. In this case -5 we multiply by 0. But in both the cases, the answer what we get is 0. So multiplication of any integer by 0 gives us 0 as the answer.